Hi everyone, I'll be introducing a new game benchmark for SafeRL called HASARD. Reinforcement learning benchmarks face numerous challenges, and there's a lack of environments tailored for particular domains. As a result, researchers often resort to ad hoc adaptations, spending time customizing environments instead of focusing on their core research. One such domain is SafeRL. The core focus among existing benchmarks has been on physics-based environments for continuous control, where the observations are mainly proprioceptive and the environment is usually fully observable. The motivation for this is clear: we don't want our robots to break stuff. But of course, SafeRL exists in other formulations, an important one being learning from imagery. Several safety environments exist for this as well. However, they all focus on safe navigation, requiring the agent to move to some location while avoiding collisions. This makes life very easy for the cost critic, which many SafeRL methods utilize. If the safety hazard is close to the agent in the middle of the screen, a collision is very likely. So the cost critic can assign a high cost value for such scenario. Whereas if no such safety hazard is visible, it's likely a low cost scenario. Although these environments are designed with their own focus in mind, there are competencies that they don't measure. To address this, we introduce HASARD, a SafeRL benchmark tailored for vision-based learning. It features these 6 tasks requiring nuanced comprehension and decision-making for efficient solutions. We include 3 levels of difficulty and 2 action spaces to both challenge future methods while offering an easier training loop. The training objective is to maximize rewards while limiting the cost. We assign these default cost budgets to each task and run some popular baselines. PPO only cares about high rewards, while PPO cost naively treats costs as negative rewards. The Lagrange and Pid-Lagrange versions closely meet the thresholds, while the latter yielding higher rewards. And lastly, P3O and PPO Sauté occasionally exceed the cost budget. We can, of course, vary the safety threshold. Adhering to a tighter budget requires a sacrifice of rewards, while looser bounds allow for more unsafe behavior. And this trade-off appears in all tasks. Since most tasks involve navigation, we can investigate what insights we can gain from the agent's movement. Taking Remedy Rush as an example, where the agent has to gather health vials while avoiding all other items, we can visualize the environment as a 2D map in a top-down view, and then overlay an evolving heat map of the agent's most frequently visited locations during training. Since PPO neglects cost, the outcome is rather straightforward. In contrast, observing the policy evolution of PPO-PID reveals a different pattern. The agent starts out similar to PPO, obtaining high rewards with high costs, but then nearly stops moving entirely to meet the safety budget, and then slowly optimizes for a safer policy. In Precipice Plunge, the agent has to reach the bottom of the cave without falling. PPO finds that the most efficient way to accomplish this is taking a direct leap down, while PPO-PID learns to carefully follow the winding staircase to mitigate fall damage, and eventually obtain nearly the same rewards as PPO. We increase task difficulty not only by tweaking configuration parameters, but introducing new mechanics. For instance, in Armament Burden, the agent has to collect and deliver weapons while not exceeding its carrying load. Level 2 adds obstacles in a more complex terrain, while Level 3 introduces decoy items and acid pits. The heat map overlays reveal how these added challenges increasingly inhibit the agent's movement, making it stay closer to the starting zone on the left. In Collateral Damage, the agent has to shoot enemy units without harming the neutrals. Higher levels increase the challenge, and the agent struggles to learn a good policy. So perhaps this can be improved by learning the levels sequentially. So instead of directly training on level 3, we split the data budget equally across levels and train sequentially. The curriculum-trained agent takes more calculated risks, achieving 30% higher rewards with the same cost, and on Remedy Rush, the improvement is even threefold. We can assess the visual complexity of HASARD by creating simplified representations of the observations, such as through segmentation. This makes it easier for the agent to learn the task. Another approach is to include the depth information as a fourth channel to the input. This again simplifies learning for the agent when spatial relationships matter. We've integrated Hazard with Sample Factory for efficient training, enabling high FPS and frequent policy updates. We run the same algorithm using identical hardware on Safety Gymnasium, the benchmark closest to our work. Compared to its out-of-the-box integration with OmniSafe, Hazard runs orders of magnitude faster. To increase the challenge, we include a setting that uses the game's original full action space. This noticeably raises the task difficulty. On level 1, the agent is often still able to learn a meaningful policy, although much slower. However, in level 3, that is generally not the case. We expect these higher complexity settings to be a proper challenge for future SafeRL methods. And with that being said, I'd like to thank you for your attention.